Very best of morning to all. Today we'll be solving the leaders in an array problem. It's an easy level problem and can be solved within a time limit of 3 to 5 minutes. Coming to the problem description, the task is to find the leaders in the array. An element of an array is leader if it is greater than or equal to the elements to the right side of it. The rightmost element is always a leader. For the given array, the leader is as follows. 17 is a leader since all elements to the right side of it is less than 2. 5 is a leader since all elements to the right side of it is a leader. 2 is leader because the rightmost element is always a leader. The reason why 4 is not a leader is because 5 is present here. All the elements to the right side of it should be less than the element in order for it to be a leader. Here, 5 is greater than 4, so 4 is not a leader. 16 is not a leader because 17 is on the right side of it. Coming to this example, here 4 is the leader and 0 is the leader. And for this example, 7 is present. No elements is greater than 7, so 7 is a leader. 4 is not leader because 7 is present here. 5 is leader because 5 is not leader because 7 is present here. 7 is leader because 3 is present here. And 3, since it is the rightmost element, it is a leader. Okay, now let us start developing strategy for this problem. So the strategy for solving the step 1. Init a list to store the leaders. Add init the current. We will have a try run later. Current max variable to the last element, the rightmost element, equal to the rightmost element, array of rightmost. Step 3, add the element to the result list. And step 4, iterate in a reverse fashion. From I is equal to n minus 2 till I is greater than or equal to 0, where I minus 1 is. Using I minus 1 and 4.1, if current max is greater than or equal to the array element, then we are swapping current max with current max is equal to array and adding current max to list. And finally, after iterating through the entire array, step 5, after iterating through the entire array, we will be printing the result list in reverse order. Okay, now let us start. Now let's have a try run on the problem. Here we'll be taking this sample 16, 17, 4, 3. Okay, so initially we'll be having a list to store the headers. Let the list be called result. Initialize the result list. So the result list will be empty initially, and we are initializing the current max to the rightmost element. So current max is equal to the rightmost element. Rightmost element is 2. Okay. Now we are adding the element to the list. Now the result list will be containing 2. While iterating in the reverse fashion, from I is equal to n minus 2, we are checking whether the current max is greater than or equal to the array I. Okay, sorry, current max is less than or equal to the array I. So we are checking 5. Here 5 is current max is equal to 2 and array I is equal to 5. So we are changing the current max. So current max is set to 5 and we are adding the current max to the list. Now I is equal to n minus 3. So current max is equal to 5 and array I is equal to 3, which is not true. So we are moving to the next element 4. Here current max is equal to 5 and the array is equal to 4, so which is not true. So we are moving to the next element 17. Here current max is equal to 5 and array is equal to 17. So we are updating the current max value to 17 and adding the current max element to the result string 17. And finally, we are moving to the final element 16. Now current max is equal to 17 and array is equal to 16, which is not true. So we are skipping that also. Since we have reached the since we have iterated through the entire array, we are planning to print the result list in the reverse order. Now the result list now the result list contains 17, 5 and 2. So since we are printing it in the reverse order, the result will be 17, 5 and 2. 17, 5 and 2, the 5 and 2 is the expected result. Okay, step 1. Initialize a list to store the VLS. Step 1. So list integer result list is into array list. Step 1 is done. Step 2. Initialize the current max element to the rightmost element. Current max to the rightmost element. So current max is equal to array rightmost element is equal to array dot length minus 1. So array dot length minus 1. Okay. Now let us move to step 3. Add the current max element to the result list. Step 3. Okay. Step 3. Current max element to the result list. Not add current max. So that step is done. And moving to step 4. While iterating, okay. So while iterating in the reverse fashion, from I is equal to n minus 2 till I is greater than or equal to 0 using I minus minus. So for in the reverse fashion, int I is equal to n minus 2, I greater than or equal to 0, I minus minus. First we are checking if current max is greater than, if current max is greater than or equal to array I. When we are setting current max to array I, and we are adding current max to the list. The list name is result. So result dot add current max. That's it. Our fourth step is done. Step 5. After iterating through the entire array. Step 5. After iterating through the entire array, we will be printing the result list in the reverse order. So we have completed our iteration, and we are finally going to print the result array in the reverse fashion. So int I is equal to result dot size minus 1, because I is greater than or equal to I minus minus system dot out dot print result I and finally we are printing a new line. So finally we have got the result, and we'll submit